Welcome. We will start with statistics. Exactly, statistics from now on. What do I mean by statistics is that it is dealing with population, sample, and other stuff. It is basically some estimation theory. So, what till now, what we have done is that it is the probability theory, and with which we are going to perform statistics from now on. Okay. So, as the first bullet says we need to understand what do we mean by a statistical problem. Okay, supposing we have a random variable x. Okay, and this random variable has some pdf f of x or mass function p of x. So we do not know what does it have. So it means what? Simply we know we have a random variable, but we are not sure whether it is a discrete random variable or continuous random variable. It means it can be anything, right? So this thing, this density or mass function is completely unknown to us. And this can be known. The form of this either density or mass function can be known down to a parameter theta. Okay, for example, uh, let me give some examples. Suppose you are dealing with exponential distribution. If you are going to say exponential distribution with one parameter, usually we write it as lambda. Okay, here I am writing it as theta. If you know one parameter, we can write down the density function of this random variable, isn't it? Okay, now consider the binomial distribution n and p. Okay, if we know the number of trials that we are going to make and the probability of success in each trial, we can write down it. Okay, so basically whenever we perform this kind of an experiment, that is the binomial experiment, the number of trials we are going to make is known to us. So here this n is a known quantity and this p is an unknown quantity, right? Okay, when it comes to statistical problems I am telling. Okay, the next example is suppose x is following a gamma distribution. Okay, of course, here it has two parameters. Here, both of them can be unknown, right? So, when initially I told that we are going to have a random variable, this one we can write it as some function of theta. Okay, this f can be either density function or mass function. Okay, and this theta can be vector as well. This is evident from the examples that I have given you. Okay, in the case of exponential and binomial, only one parameter is unknown. Whereas in the case of gamma, we have two parameters which are unknown, right? That can be the case. Okay, and in the statistical problem, population means the collection of all possibilities, or we select a particular set as an universe, and in that set only we are going to conduct the experiments. For example, if we are going to find out the average salary of outgoing students. So if you are going to calculate this one, this is your statistical problem. You need to find out the density or mass function to this. Average salary of outgoing students. So suppose in the institution, there are 7,000 students. There are in total 7,000 students, out of which 1,500 are final year students. Okay. So in the final year students, out of this 1,500 students, let us say that 1,350 students have got placement. Okay, so now if we are looking for the average salary of outgoing students, so this 1,500 is the outgoing students, so your population size is 1,500. Okay, and the chances for all the students to get placed were equal, isn't it? Okay, only out of the placed students we are going to find out the salary of all the 1,350 students, and we'll make an average of it. and that is what is going to be the average salary of an outgoing student. Okay, suppose if you are going to calculate the height or weight of the students average height of all students. Okay, average income of a citizen in Kozhikode city or Coimbatore city or Delhi. Okay, this can be the case. In these cases, what is the thing? If we are talking about Delhi city, the number of people, the total population is the population that we mean here, right? And sample means, okay, when supposing the case New Delhi has, let us say, I'm not so sure about the actual population. Let us say that there are 25 lakh okay, 75 lakh 25,437 people. Now that I need to find out the average income of each individual. So it is practically okay. 75,000 seems 75 lakh seems too high. So let us take 5 lakh 25,000 437 people. If you see this many, we cannot go and ask the salary of all these things, all these people. So what do we do is that we randomly pick about 1,000 or 5,000 people. Okay, and we perform the calculation for this 5,000 people and draw that rupees 15,750 as the average salary out for this 5,000 people. So we will come to a conclusion that the average salary of the people in Delhi is 15,750 based on the sample that we have taken. Okay, and remember, the chances of selecting this 5,000 people was equal to everyone. There was no biased. Everyone were identical. Okay, and they are all independent. So basically we have to make sure that we are selecting the samples in a way that it is independent and identically distributed. So in short, it is written as IID. Okay. Next one is the statistical inference. So basically, it means what we have done here. Actually, we have selected 5,000 people, and from the 5,000 people, we gathered their income information and we calculated the average income. So it is basically drawing some conclusions about the total population based on the sample. Okay, based on the sample means how did we get it? We have obtained some information from the sample. Okay, we perform some calculation and drawing some conclusion. Okay, so this is known as statistical inference, right? The next one is the random sample. So random sample means the choice of sample was not biased, and it does not depend, like the selection of one sample does not depend on the selection of other sample. So that is basically known as random sample. Okay, and we have an another term called statistic. So supposing from the total population you have obtained a sample of size n, and the sample, let us say it as x1 through xn. Okay, and we define some function, that is function of the random variables in the sample. So now this t is an another random variable which is a function of the random variables, and this is known as statistic. Okay, do not get confused with the terminology statistics, mathematical statistics and statistic. That is a subject of this interest, and this is a function of random variables in the sample. Okay, Now we have the another concept, that is the distribution of the population. Okay, when we select a sample from a population, it means what? This population is having some probability distribution. Okay, probability distribution. Again, here we are not specifying whether it is continuous or discrete. Okay, probability distribution f of x with mean mu and variance sigma square. Okay, from this population only we collect a sample. Of course, the sample, all the entries in the sample will have the same probability distribution, mean and variance. That means expectation of xi is going to be mu and variance of xi is going to be sigma square for all I runs from 1 to n. Okay, now that this is constituting a sample, isn't it? Now what would be the distribution of this statistic? So basically we are going to define the joint distribution of the sample x1 through xn is, which is denoted as f of x1 to xn, which is nothing but the product of individual mass or density functions, right? Moving further, we have a sample, random sample from a population having this thing. Okay, then the same thing, whatever I have written here, the joint distribution I have written is given here as well. Okay, and moving further, we have the definition of a sample mean. Okay, suppose this is your random sample. The sample mean is defined and denoted as x bar, which is just the usual thing. You just add them up and divide by the number of items in it. Okay. To find the variance, use the formula xi minus x bar, which is the sample mean whole square upon n minus 1. This is your sample variance. Okay. Once you have a variance, just take the positive square root and that is your standard deviation. Okay. Here you have an example to calculate the sample mean and sample variance for this thing. Here, just count the number of entries. You have 4 plus 5, which is 9. So your n value is 9. So basically your x bar is going to be what? 44 plus 71 plus 63, 59 plus 68 plus 46, 69, 54 plus 48, everything divided by 9. And this is going to be 58. Okay, now that you need to calculate this s square. So in order to calculate x square, you have all these quantities, isn't it? So from all these quantities, you will have to subtract your mean. So you have to subtract 58 from all these quantities, and whatever the answer that you are getting, you will have to square it and finally add these quantities, and this quantity has to be divided by n minus 1. That will give you, that is your sigma square, which is 109. Okay, so it is not sigma square here, it is denoted as s square. Okay, so from this you have calculated your x bar, and from this, you doing all this calculation, you will have to find out your s square. Okay, so to perform these theories, that is the statistical theory, you need to be well versed in using calculators. Okay, now moving further, we have few more definitions. The first one is the parameter. It is the statistical measure obtained from all observations in the population. It means, suppose in the previous instances that I have specified, we were calculating the average income, right? So it is basically dealing with the mean. Okay, and that if you are testing the lifetime of a electric bulb, you expect that the very uh, it should go up to the variance of 100 hours. Suppose you expect the lifetime of an electric bulb is 1000 hours. Okay, now that you are not interested in this 1000 hours, but you are interested in the variance, that this variance should not be more than 100 hours. Like if it is glowing for 900 hours to 1100 hours, the company has no issue, it's perfectly fine. But if it is glowing less than 900 hours or more than 1100 hours, there is an issue. Because less than 900 means, anyway, in the product we will say some conditions apply. In the conditions it will have this much of deviation, and everything we would specify, the company would specify. Okay, but if it is glowing for more than 1100 hours, the consumer is happy with that, but the company may go in loss, right? So in either case, that should not happen. Okay, so now this is the measure that we are going to observe from the population. Okay, so basically what is the parameter upon which we are going to perform the statistical calculation? That is what we call it as a parameter. Okay, here is where we have given the definition of a statistics. It is a statistical measure obtained from the elements in a sample. So basically the statistic, initially I said that this is a function of the sample. So from the sample only we are going to obtain some statistical measure, and that is what we call it as statistics. For example, it can be sample mean or sample variance or anything more. Okay, when we proceed further we will see more of that kind. Okay, so now that we have seen the definition of a parameter and statistic, reading the definition again, we understand that this parameter is a constant, whereas the statistic is a random variable, and which depends on the sample that we have selected, right? Okay, moving further, what do we mean by a sampling distribution? So statistic is a random variable. This random variable should have some distribution, right? And that is what we call it as a sampling distribution. So basically it is the joint probability distribution that we have discussed here. Okay, and coming back to this, the sampling distribution can be found for a mean or variance and for anything else. Okay, so basically when we were saying that x follows a gamma distribution, the parameters are alpha and beta, so we are in a need to find out that alpha and beta from the sample. That may be the case. Okay, and standard deviation of the statistic is the standard error of the statistic. Okay, so with which I end this video. We will have more discussion in the upcoming videos. Thank you.